What is going on, guys? It's Bucky again, and welcome to your second physics tutorial. Now, before I even get started in this tutorial telling you guys what I'm even going to be teaching, I want to say this. I have a new microphone that I'm using in this tutorial, so go back and listen to my last tutorial, then listen to this one, and whatever you guys vote is the better microphone is the one I'm going to be using for the rest of my tutorial. So it's up to you guys to decide on my future of what microphone you guys want to listen to and what microphone I'm going to use. So that being said, I want to talk to you guys about some alternative or basically different variations of ways we can write scientific notation. Now, the reason I need to teach you guys about these different ways we can write scientific notation is kind of a stupid reason, but I'm going to try to explain it. You know, back in high school, or maybe you're in high school now, different teachers have different requirements for like writing a paper. Your English teacher might be like, all right, make sure you write this paper in cursive. And your computer teacher is like, all right, make sure you type this paper out on the computer. And another teacher is going to be like, all right, make sure you just use basic handwriting. When the truth is, it's like, dude, come on. Does it really matter how I write my paper? You can read it any way I write it. So why are you giving me these stupid rules? Well, that's kind of what I have to teach you now. Different scientists and different teachers, depending, how they grew up, what country they lived in, how they practice physics, they are so anal about writing scientific notation a different way than you probably learned. So I'm going to be teaching you all these weird little variations, and then no matter what textbook you read, no matter what tutorial you're watching, you're going to be able to understand what all these little weird symbols mean. So the very first thing I want to teach you guys about is something called alternative form. Now, all this means is some scientists are so anal where they make sure the number to the left of the decimal point is 0. So you know how we had numbers like 1. Let me go ahead and switch to the right layer. We had numbers like 5.26 times 10 to the fourth, where they're saying, all right, here's the decimal point right here, and this number is not a 0, so that is invalid. So what they would do is they put a big old line through this and say wrong. So what alternative form is it's basically saying, all right, the number to the left always has to be 0. So you'd have something like 0.362 times 10 to the fourth. That's good. 0.861 times 10 to the negative fifth. That's good. So basically all you have to remember, whenever your teacher says, make sure you're writing in alternative form, make sure that this number is always 0. And that's it. That's good to go. So the next thing I want to talk to you guys about is the multiplication symbol. So in our last tutorial, I wrote scientific notation like this. Let me give you guys a quick example. Yeah, that's probably going to happen a lot. So you guys are probably just going to have to deal with it. 5.81 times 10 to the fourth power. And again, as you can see, I use the x for multiplication. But some scientists, like I said, and some teachers are so anal, they make you write a dot instead of the multiplication sign. So it would look like this. 5.81 times, and your time sign would look like that, 10 to the fourth. Now this thing right here, this way of writing it and this way of writing it is the exact same way. However, some teachers make you write that dot rather than the x. And by the way, in my upcoming tutorials, I am never going to write the dot, and I'll tell you why. Whenever you have a number written in scientific notation like 5.81 times 10 to the fourth, it can get really confusing sometimes. This dot and this dot, especially if you don't move it exactly middle, and this one isn't sitting exactly on bottom right there. So I mean, one dot is enough. I don't need two floating all around my numbers. So that's why I use an X. It's a lot easier than writing a bunch of dots. However, if your teachers say use a dot whenever you're showing your work, then that's what you got to do. Now, aside from that, some other teachers make you use an asterisk, which just throws a whole nother wrench into your problems. So you'd have something like 5.81, and then you have to make a stupid asterisk like that, 10 to the sixth power. So again, it all depends on, I needed to go over all these signs because I didn't want you guys to get confused whenever you saw an X and a dot and an asterisk. I didn't want you guys to think that those were all different meanings. They all mean the exact same thing. It just depends on your preference and your teacher how stupid they are. So the last thing I want to talk to you guys about is plain text notation. Now what plain text notation is basically this. Scientists long ago, back, tens and tens of years ago, they wanted to send, scientific notation across emails, and they wanted to be able to type it in typewriters. Well, I don't know if you guys ever used the computer before, but if you try to do something like this, 10 to the fifth, there isn't really an easy way you can type that. You need to type a whole bunch of like combinations to get exponents to show up whenever you're typing. So they made an easier way to do that, and that's through the use of plain text notation. So plain text notation pretty much means how can I type scientific notation or write it on a typewriter easily? And for that, they used no exponents whatsoever. So I threw a couple examples up here right now. 3.58 E6 is an example of plain text notation. What this means is 3.58 times 10 to the sixth. So it's pretty much E equals times 10. Well, you can obviously see, I don't need to explain to you guys what it means. So 7.014 e to the negative 8 pretty much means 7.014 times 10 to the negative 8. So basically, that's what it means. So it's basically just a way of writing scientific notation that's easily noticeable whenever you're looking at it on a typewriter or email or calculator, something like that. And this down here is just an alternative version of plain text notation. And the reason I wanted to go over these little caret signs, and by the way, that's the symbol above the 6 on your keyboard. The reason I want to go over that is because a lot of scientific calculators you use nowadays, you can't like throw in an exponent and they can't display it on their screen like this. So instead what they do is they type it like this. So you see this a lot whenever you're working with calculators because, again, they have the same problems that computers do. It isn't really easy for them to display exponents, so they need, a simple plain text way to display them. So that's why we have plain text exponents, aka plain text notation, whatever you want to call it. So now that I went over all these alternative variations of scientific notation, no matter which one of these things you see, whether it's plain text notation, various multiplication symbols, or alternative form where you need the 0 to the left of the decimal point, you guys should be able to understand what these numbers mean and how to use them and how you can convert them to, something that you feel more comfortable working with. So with that being said, thank you guys for watching. Don't forget to subscribe, and I will see you guys in the next tutorial.